Okay, welcome everybody. Today we're going to discuss dimensional analysis, which is a very important tool in chemistry. It's going to be used very often in order to relate units to each other. We're going to use it a lot in the second semester, so we need to kind of figure out how it works, okay? So first off, dimensional analysis is also called the factor label method. The labels that we use, aka the units that we use to describe numbers, are going to be very important in this method, okay? It's just a mathematical process. Used to convert values from one unit to another, okay? Our calculations are going to be set up so that the units cancel each other out until the desired unit is the only one that's left. So for example, if I was taking a known amount in grams and I needed to convert that to milligrams, I would start off by writing down my known amount in grams and then setting up my units so that they cancel each other out. Why do these guys cancel each other out? Well, if I have the same unit on the top and on the bottom of my dimensional analysis, then they're kind of like a fraction, like 4 over 4. Now if you simplify that fraction, 4 over 4, it's equal to 1. And since we're multiplying in dimensional analysis, multiplying by 1 doesn't change the value. So the amount is not changing. We're simply canceling out the units by setting them up as a fraction that cancels out so that our unit changes from one thing to another. So for example, if I needed to take 3 days and convert it to hours, I would set it up so that days cancels each other out and I would be left with an amount in hours, okay? The amount of time would be represented by different numbers and different units, but it would still be the same amount of time because multiplying by 1 doesn't change the value. The overall quantity would be the same, just expressed using different amounts and different units, okay? In order to do this, we're going to have to use conversion factors. So what is a conversion factor? It is a statement of equivalence. Okay, so for example, 1 foot is equal to 12 inches. That's a conversion factor. Now, when we set up things in dimensional analysis, we're going to express them as fractions. So we'll have one number on top of the other. So I would rewrite it like this. 1 foot is equal to 12 inches. I could also write it the other way around. 12 inches is equal to 1 foot. It just depends on how I need to arrange the units. So let's take a look at an example in order to understand this a little bit better. So the first step in dimensional analysis is to identify the known amount and the unit you want to convert it to, the wanted. So for example, if I have this problem here, I need to convert 6 feet to meters. The known quantity that I'm starting with, the known amount, is 6 feet. Okay, that's the number from the problem that I'm starting with. I want to end up turning that into an amount in meters. This is my wanted. So step 1 is really just reading the problem, okay? Step 2 is going to be to identify the conversion factors that could be used to solve the problem. Okay, so for this you may consult a conversion chart. And so I have one here that you guys will get a copy of. And it has all kinds of conversion factors here, statements of equivalence. Now, I don't see a statement of equivalence directly between feet and meters. I have 1 foot equals 12 inches. I have 1 foot equals 30.48 centimeters. I'm going to start with this one because I know that in the metric system, I can convert from centimeters, millimeters, decimeters to meters pretty easily, okay? So I'm going to use 1 foot equals 30.48 centimeters. And then I'm going to relate centimeters to meters using this conversion factor right here. There are other ways that you could do this. You could have said 1 foot is equal to 12 inches, 1 inch is 2.54 centimeters, and then 100 centimeters is equal to a meter. It's a little bit longer, but you should still get roughly the same answer, okay? Because again, our quantity isn't changing, just the units we're using to describe it. So again, I said that the conversion factors that could be used in this one is 1 foot is equal to 30.48 centimeters, or 100 centimeters is equal to 1 meter. And we are going to write them as fractions whenever we set up our dimensional analysis, okay? So when we set up our problem, we're going to set it up so that that known quantity, that known amount from the problem goes first at the top, okay? We're going to then line up our conversion factors so that the units cancel each other out diagonally, top to bottom. Again, because whenever those units are represented on the top and the bottom, they become like a fraction that's equal to 1, okay? So my known amount was 6 feet. I'm going to start with 6.0 feet, okay? And I know that my units have to cancel out, so if I have feet on the top here, then something about feet has to go here. So what do I know about feet? I know that 1 foot is equal to 30.48 centimeters. So let me go ahead and fill in this conversion factor right here. 1 foot is equal to 30.48 centimeters. And now the unit feet cancels out from top to bottom. The numbers are not the same, so I'm not going to cross off the numbers, but the unit does cancel out. So foot on top and foot on the bottom cancel each other out. So right now, if I was to solve this problem, my answer would be represented in centimeters. But I didn't want to calculate centimeters, I wanted meters, so I need to go further. And if I have centimeters on the top here, then something about centimeters needs to go on the bottom here. That way my units will cancel each other out diagonally. The other piece of information I have is that 100 centimeters is equal to 1 meter. So let me fill in the conversion factor. 100 centimeters is equal to 1 meter. And now my units cancel each other out, and I'm left with meters, which is the unit that I wanted, okay? So once my dimensional analysis is set up with my units canceling each other out diagonally, it's time for me to solve the problem. This is the easy part, okay? You get a calculator, so all you have to do is take all the numbers on the top and multiply them. That'll give you a top number. Then what you can do is you can multiply all the numbers on the bottom, and that'll give you a bottom number. The top number divided by the bottom number will give you your final answer. Now, just like we've been doing all week, anytime you give an answer, you have to express that answer to have the correct number of significant digits. So let's take a look at this problem here. The first step is to multiply all the numbers on the top. So I'm going to take 6.0 times 30.48, and then I could put times 1, but like we've been saying, multiplying by 1 doesn't do anything, so I'm just not even going to worry about it. Okay, so my top number is 182.88. Then I would multiply all the numbers on the bottom, but 1 times 100 is going to be 100. Again, multiplying by 1 doesn't mathematically change anything. So I really don't have to multiply there. My bottom number is 100. So then the last step is to take my top number, which is 182.88, and divide by the bottom number, which is 100. and I get this value in my calculator. Now, in order to represent my answer correctly, I have to make sure that I round to the correct number of significant figures. If I look back at the problem, my known was given to me 6.0. That's 2 significant figures. So I need to round my answer to contain 2 significant figures. I'm going to keep the 1 and the 8, and then look at the next number to round. It's a 2. So 8 is going to stay the same, and my answer is going to be 1.8 meters. Again, my number has to be followed by the unit representing it, okay? There's another way to put this in the calculator. You can kind of combine the steps if you use parentheses. So you could do open parentheses, multiply all the numbers on top. 6.0 times 30.48 times 1, but we don't have to do that. Close the parentheses. Then hit divided by and open a parentheses and put in all the numbers at the bottom that need to be multiplied. In this case, it's just the number 100. We still get the same answer doing it all at the same time. So either way you calculate it, you should get the same answer. This would still be 1.8 meters. I hope that this helps. Tomorrow I'm going to be checking your notes for completion, and you guys need to write a good summary at the bottom of your notes. In order to write a good summary, you need to answer the essential question that's at the top on the front of your notes. How is dimensional analysis used to convert a value from one unit to another? Your summary only needs to be a sentence or 2, so go back through the notes and write a good summary that answers that essential question. Thank you.